Class, what is up? Welcome to our first video of Chapter 4. We just call this Everything You Ever Wanted to Know About Triangles. Technically, it's a few chapters put together, I think 4.2 and 4.9, and yeah. So, we're back. We're working on triangles now. Everything in Chapter 4 will be triangles. And the first thing we need to do is we need to be able to classify triangles. Now, when I say the word classify, I mean to group and figure out what type of triangle we are looking at. So, when we have an acute triangle, I could draw anything like this. That's an example of an acute triangle. And I know that this is acute because there are 3 acute angles. Alright? Well, if I have an equiangular, so equiangular, this might be a little bit of a new word, equiangular, equilateral, equiangular. Equiangular means equal angles, equal angles. So now my picture is going to look pretty similar to this first one, except I'm also going to say that if it has to have equal angles, well then all 3 angles must be congruent. So maybe I put some arc marks in there, something like that. And so now what I will say is 3 congruent acute angles. Alright, so the only difference really between acute and equiangular is that in an acute triangle, just all of the angles must be acute. But in an equiangular triangle, all 3 acute angles must also be congruent. Alright? And we move on. We now have right triangle. So a right triangle must have a what in it? Hopefully you guys already said it out loud. It needs to have 1 right angle. And an obtuse triangle must have 1 obtuse angle. Alright, so guys, this is really what you're looking for. If we ever ask you to classify triangles by angles, you need to kind of figure out what type of angles they're made up of. Alright? Now, kind of going a different way, when we classify triangles by sides, now what we're looking for is we're looking for the number of congruent sides. So an equilateral triangle means equal sides. So I know that an equilateral triangle will look something like this. But more importantly, to specifically say it's equilateral, I must put tick marks on all 3 sides, because now I have 3 congruent sides, and that is what equilateral means. 3 congruent sides, or all sides equal. Now, isosceles is a little different. I could draw a picture something like this, and what I would need to know here is that maybe I have something like that. So now, with an isosceles triangles, we need to have at least 2 congruent sides. Hopefully you guys can visualize and imagine. There are other ways to draw an isosceles, right? It could be something like this, right? That's isosceles. And what's also kind of a little tricky, equilateral triangles are still isosceles. Alright, last one, scalene. I'll give you this first. 0 congruent sides. And so I'm really looking for something like this. Boom, boom, boom. And the important thing to know is that each side must be different. And that's why I used these tick marks. If I don't have any matches, then I don't have any pieces that are congruent. So I know that having a 1, a 2, and a 3 mean that each side is separate, or each side is different, different length. Okay? So there you have it. And actually, maybe I should have... no, I'm good. Alright. Okay, so that's how to classify triangles. Now we're going to hone in and kind of think a little bit more specifically about isosceles triangles, okay? So, legs of an isosceles triangle are the congruent sides of an isosceles triangle. So if I draw another isosceles triangle, alright, I would say that. This is a leg, and this is a leg. And I know that because those are my pieces that I said were congruent. All right? Now the base angle is the angle formed by the legs. So if I have to find an angle that's touching both legs, hopefully you guys agree with me, that angle is right here. And we call that the vertex angle. And again, it's the angle formed by the legs, excuse me. The base is the side that is opposite the vertex. All right, opposite the vertex. So this would be my base. And then lastly, guys, not too bad, but we have two base angles. And base angles are just the angles that have the base as a side. All right? So this is something that you should probably kind of, well, yeah, I guess memorize this. Just know that the vertex angle is the one that's in between both of the legs. The base angles are the angles that are touching the base, etc. All right? Okay. Let's move on. A little bit more notes, and then we'll be on to some problems. All right. So we have some theorems that we need to go over here. So the first theorem, if two sides of a triangle are congruent, I knew that because I'm talking about isosceles triangles, and so I know that two sides are going to have to be congruent. So if two sides of a triangle are congruent, then the blank that are blank, those sides are... Oh, okay. Let's go back to our old picture for a second. All right. What we're going to be able to say here is if we have an isosceles triangle and we know that the legs are congruent, well then the angles opposite those sides are also congruent. So that's what we're going to write here. Then the sides that... Did I say sides? Angles. The angles that are opposite those sides are also congruent. So in picture form, if I gave a picture something like this, A, B, C. So what I'm basically saying, guys, is if AB is congruent to BC, then angle A is congruent to angle C. Alright, so what's really important, guys, is that it's always across from. If I give you these sides, then you get the very two specific angles that are across from. Now the funny thing is it works the exact same way, but in reverse. So if two angles of a triangle are congruent, then the sides that are opposite those angles are congruent. So my picture doesn't have to change much, but now I'm giving you congruent angles, and so you need to know congruent sides. Alright, so we would say if angle A is congruent to angle C, oh, my bad, I didn't mark B and C. So if angle A was congruent to angle C, then AB is congruent to BC. Alright, so if sides, then angles, and that's what I usually say, guys. If sides, then angles, or if angles, then sides. So this is important for us to remember. Alright. Oh my gosh, so many notes. This is boring. Alright, equilateral triangle corollary. If a triangle is equilateral, then it is equiangular. Alright. So basically it's just saying if we know that all the sides are congruent, then we know that all the angles are also congruent. So that's important. And then lastly, the converse of that. If a triangle is equiangular, then it is equilateral. So once again, my picture would have congruent angles leads to congruent sides. Something like that. Okay? Okay. Holy cow, that is enough notes for the time being. Let's do some problems, then we'll call it. So, if we look up at something similar to the top, classify the following triangles by sides and angles. We need to remember that if we want sides, we're basically counting up the number of congruent sides. Alright? Well, I see 1 tick mark, 2 tick marks, not a third. So if I have 2 congruent sides, that is an isosceles triangle. So this is isosceles. It also says to go by angles, and remember, angles depends on like the type of angles you have there. So I notice I have an acute, and another acute. 3 acutes. Oh, 3 acutes is an acute triangle. So I know that this is both isosceles and acute. Now when I look at something like number 2, I notice that all 3 sides are different, 3, 4, 5. So this is a scalene triangle. And I see 1 right angle. I know that if I have 1 right angle, then I have a right triangle. I should probably be putting triangles here, but whatever. Alright. Okay. Last one. 3, 6.4, 5.8, 9. Okay, hopefully you guys notice again, no sides are congruent. So I definitely know that it's scalene. When I look at the angle measures, I have a 40 and a 45. Those are both acute. Oh, but 95 is bigger, so this is obtuse. Alright, so that is how you would classify. And then we get into some problems where we actually need to solve for angle measures or side lengths, excuse me. So if we look, find the side lengths in the following triangles. Oh, this isn't going to be too bad. Look, first of all, we need to know what type of triangle we have. Oh, I have 2 congruent sides, so I know that this is isosceles. But honestly, guys, what's more important is the fact that I know these 2 pieces are congruent. I know LK is congruent to KJ, which then means that the measure of LK has to equal the measure of KJ. And so, guys, I can just plug in. I know that x plus 3.2 must equal 4x minus 1.3. Okay? Well, we do a little bit of solving. Let's move the 1.3. Let's take away the x, and we're left with, what is that? 4.5 equals 3x, or x equals 1.5. All right? Now, it does say to find the side lengths, so we would not be done yet. I would need to go in and I would need to plug in. So, LJ equals 5 times 1.5 minus 0.2, which is, what is that, 7.5, 7.3. Please use a calculator if you need it. JK, or KJ, however you want to, JK, is 4 times 1.5 minus 1.3, and that is 6, so 4.7. Now, to test, you absolutely could plug in. So we know that LK is equal to 1.5 plus 3.2, which is still 4.7. We also knew that LK and JK were congruent, so you really didn't even need to do this last one. You could have just immediately said LK was 4.7. Okay, equilateral is going to be pretty similar. I guess a little different. We need to remember that if it's equilateral, then all sides are the same, or are congruent. Okay, so you just got to pick 2 sides and solve for y. I think I'm going to pick GF and GH. So I'm going to say that 3y minus 4 is equal to 2y plus 3. And I'm going to solve. So minus 2y plus 4. So cancel and cancel. I end up getting y is equal to 7. Alright, I'm not quite done. Once I know y is equal to 7, I need to plug in. So if I get GF is 3 times 7 minus 4, that's 21 minus 4, that's 17. Well, we should know what? Every single one of these should be 17, because if it's an equilateral triangle, which we were given, right? So I really don't even have to go through this anymore, guys. I can just say GH is 17 and FH is equal to 17. Alright? Cool. We're getting there. Number 6. Number 6. A manufacturer produces musical triangles by bending pieces of steel into the shape of an equilateral triangle. How many 4-inch triangles can the manufacturer produce from a 100-inch piece of steel? Okay. Well, we need to know what a triangle kind of looks like, right? Triangle looks something like that. And we know that each side is going to be 4 inches. How did we know that? Well, because it was an equilateral triangle. Well, this is an idea we haven't necessarily talked a ton about yet, but we know that if we're trying to make triangles out of a 100-inch piece of steel, well then each triangle is going to take 12 inches. Alright? We know that each triangle will cost us basically 12 inches of steel, and so what we would have to do, if we have 100, we would just divide the 100 by the 12. Okay? Now, that should be, what, 8.33, I think? However, if we want to know how many triangles can be made, we would have to say, what? 8 triangles. Okay. Oh. Alright, almost done. Here we go. Find the value of the variable in the measure of the indicated side or angle, if necessary. Explain. Alright, we want to know what x is. Now, we need to use one of those theorems that we used on our last page of notes, and we need to understand that right now, if I'm just given congruent angles, well then I don't know anything about the sides. But if we know our theorem, if angles, then sides. And you know what? Just because it's the first time, I'm going to write this even better. I'm going to say if angles congruent, then sides congruent. I think that might make more sense. Alright? In picture form, you might see it like this. Any of these are okay for an explanation for me. But what the whole idea here is if we have these angles congruent, then we know that the sides opposite those angles are also congruent. So I can make tick marks on my picture. And now I could say df equals de, 12 equals x plus 3, x equals 9. Okay? And again, guys, there's not any extra explanation needed. This is the explanation we need to see. We need to know that you know that if we have congruent sides in a triangle, congruent angles in a triangle, well then we know that the sides opposite of those angles are also going to be congruent. Okay? So there is a long introduction to some Chapter 4 concepts. Hopefully not too bad. Hopefully you guys are starting to get the hang of it. And of course we will work more in class. Have a good one.